Hello all and welcome back. So in this video, let us now move forward and implement inserting at tail of our linked list. So insert at tail. Before that, just one thing which we forgot in the last video, finding out the complexity of my insert at head function, right? So the same actually is pretty easy if you think about this. We are just doing some constant operations, right? It doesn't matter how long your linked list is or if it has anything or not for that matter. You just are changing the head by doing some k operations. So pretty straightforward that the complexity is going to be O of 1, right? So complexity is O of 1, O of n to the power 0. So let me write that down as well, everyone. So yeah, time complexity inserted head as only constant operations implies O to the power O n to the power 0, which is equals to O of 1. So it doesn't matter how long your linked list is. Inserting at head is always O of 1 as compared to O of n for our array, right? Great. Cool, everyone. Now let us see insert at tail, right? Again, let us quickly draw a linked list. So this is the node. I'm going to make sure to always draw this so that you also get into the habit. Right. Now let me join this as well. Cool. So now if I am inserting at tail, everyone, then what we have to do, I think it's pretty easy to understand. We have already done similar kind of a work in your print take input function. So we just have to make sure that we are able to find our tail, right? So let me draw a new node as well. Let's say this node as of now, it is 100 and it is pointing to none as of now, right? Great. So I just have to make one connection here, which is first I have my head, which is equals to this. So my head is equals to this particular node. I have to make a temp variable here. So let's say create a temp variable. Using that temp variable, I'm gonna go and find my tail. Now we have already seen this. The tail is where the next is none, right? So once I'm able to reach to my tail, I just have to ask my tail that, hey, can you please make a change? And now please point to this node. And if you do this, because the last of this node is none, you are all set, right? So yeah, I think this is pretty straightforward again. Just let us compare this again as well with our array. Now doing this because it is normally asked in interviews. When we have an array or a list, right? So compare with array or list. Now adding to tail is normally an append function. We have seen that list normally works on the principle of your dynamic array. So we will have to take the worst case, right? We will have to take the worst case. In the worst case, we will assume that we have to create a new array, right? And we will be adding toward the end of it because we cannot assume that there is always the space to add. So we will have to create a new array. Let's say this array is completely full. Okay. And then we will have to create a complete new array, copy everything, and thus the complexity will become O of n, time complexity. Because we will have to make sure that we are increasing our array, right? So if the space is not there, that is how we do it. That is how append function actually also works. We have seen this already, everyone. Now let us write the code for insert at tail, everyone. Let us go to the code and say, okay, so yeah, we will just call it here only def insert at tail, right? So we will be getting the head and the data. Great. The very first thing I think we can make a note that is common, making the note. Now, if you think about this, there is just one case in inserting at tail. What if your head is none? So if there is nothing in your head, right? Like the linked list is empty. So let us write that down. That's a special case. when linked list is empty, we have to just return the new node. I hope that makes sense, right? So if the linked list is empty and you are trying to add anything, so it's very analogous to if your list is empty, okay, or array is empty and you are adding an element. So that's the first element. So you will have to change your head and it will become the new node. So again, what we are going to do, we have to make this check first. If my head is none, then I can just return this new node as it is, right? So if the list is empty, then new node becomes the head. Straightforward, right? So again, you have to always make sure that you are handling these edge cases, right? So if that's the case, then of course we can do it. If not, if this is not the case, then I'm going to write a loop, right? So I'm going to take a temp first. We don't want to lose our head. So temp is equals to head, while temp dot next is not equal to none. Okay. What we are going to do, temp is equals to temp dot next. Now this is the same thing which we have done here. So I'm pretty sure all of you will remember. This is what we did in our take input function as well, right? So when we need to get to the tail, once we get to the tail, we are just inserting it. So pretty state and common thing we are doing here as well. We are just inserting. So in temp dot next, we will have a new node. And once this is done, we can just return head. Great. I think this should work. So to check it, just let us have this call again after inserting at tail now. Okay. Let me just copy and comment it so that you can use it at your end as well. Head, head. I'm commenting this for the timing. So yeah, great. Let us now try to run this, everyone, and see what exactly going to happen. So yeah, once I run this, it is asking me for the value. Enter the value of node. So let me enter 10, then 20, then 30, and -1. So this is my first list, 10, 20, 30. And after inserting a tail, it is saying that it is added 100. Okay. So gonna run this one more time. Let's run this one more time. This time I'm passing an empty list. So -1. I think, yeah, it seems to work. It is not giving us the error, right? Yeah, let me just do that. Let me just remove this and show you why this particular condition is required. If you remember, I told that if you are calling any attribute on none, it's going to be a problem. So if your head is null, if your head is none and you call this none dot next, it's going to give you an error. And see, if the list is empty -1, we get an error. None time object has no attribute next, right? So that's the reason we have to always make sure that we handle such cases. Great. So yeah, I hope this is clear, everyone. Now what you have to do, I have a homework for you, assignment. You have to make sure that you implement this same function, but recursively, right? So this is some function which we can very nicely do using recursion. So you have to do this at your end and write the code for insert at tail recursion. Now, one thing, let us move forward and see the overall time complexity of this function. So time complexity, I think it should be a lot clear. We have already seen this in our take input function. Time complexity is going to be O of n. The reason for that is we have to travel to our tail, right? So we start from head. One by one, we go till we reach the tail. And once we are able to reach the tail, then we add here, right? So if the linked list is of n size, I will have to make sure that my loop runs for n-1 times, right? So O of n is the time complexity as we traverse to tail. Now, please make sure that you understand this. I don't want all of you to remember this. That's why I'm making sure to compare and tell you while we are writing the code. Okay. Cool then, everyone. Please try the recursive way of doing this in the assignment section, the next assignment. And yeah, we should be good. Let's meet in the next video. Thank you.